Let's take a look at this problem. Uh, I really don't know how to approach this problem. I'm going to pretend that this is 5 over 3y minus 1/2 equals 5 over 6y minus 1/2, or minus 1/12. I'll base that upon that it's not the first part of the semester, so it's probably not a linear equation. It's probably a rational equation. Now, if this is 5/3 y, then you'd work this differently. Okay. Well, our first step, I'll show all the steps actually, is you factor all of your denominators. Well, 6 is 2 times 3, y, and 12 is 2 times 2 times 3. Now, we're trying to get rid of our fractions, so we want to figure out what the LCM is of all our denominators. So I'll start with our first number. I'll start with 2. Now I'm looking for the greatest number of 2's in a single denominator. There's none here, there's 1 here, there's 2 here. So the greatest number of 2's in a single denominator is 2 of them. Now I go to my next number, 3. I'm looking for the greatest number of 3's in any denominator. I got 1 here, none here, 1 here, 1 here. So the greatest number of 3's in a single denominator is 1. Then I'll go to the y. We're looking for the greatest number of y's in a single denominator. There's 1 here, none here, 1 here, none here. So the greatest number of y's is 1. So this is going to be our LCM. Now 2 times 2 times 3 gives us 12y. So I'm going to multiply it times everything. I'll multiply it times this first fraction, times the 5 over 3y. I'll multiply it times the 1/2. And I'll multiply it times the 5, and I'll go ahead and put this back together. 2 times 3 is 6y. And minus 12y, and I'll multiply it times this fraction, which I'll put it back together. 2 times 2 times 3. 2 times 2 times 3 is 12. Okay, let's see what cancels. The y's cancel here. 3 and 12 both divisible by 3. 3 divided by 3 is 1. 12 divided by 3 is 4. Here, 2 and 12 both divisible by 2. 2 divided by 2 is 1. 6 divided by 2, or 12 divided by 2 is 6. Here the y's cancel. 6 and 12 both divisible by 6. 6 divided by 6 is 1. 12 divided by 6 is 2. And here the 12's cancel. So let's see what we have left. 4 times 5 minus 6y times 1, that 1 drops away, equals 2 times 5 minus 1y or y. Okay, 4 times 5 is 20, minus 6y equals 10 minus y. Now I want to get everything with a y on one side, numbers on the other side. So I'm going to take the negative y here, take it to the left side. And I'll take the 20 and move it to the right side. You take anything across your equals, your sign changes. So negative y becomes a positive y. The 20 becomes a negative 20. Combine together like terms in a step. Negative 6y plus y is negative 5y. Combine together numbers. 10 minus 20 is negative 10. Last step. Divide both sides by a number in front of your y. Number in front of y is a negative 5, so I'll divide both sides by negative 5. And we get y is equal to 2. These negative 5's cancel. Now we could check that if we want to. Put 2 in here. I'm doing it just because I'm a little bit tired and I want to make sure I didn't screw up. Put 2 here. 3 times 2 is 6. So that gives us 5, 6 minus 1/2. And we're wondering if it's equal to that. So if I put 2 over here, I get 6 times 2 is 12, so that's 5 twelfths minus 1/12. Now we get a common denominator here, which would be 6. So I rewrite the 1/2 as 3 6. We're wondering if that's true. 5 twelfths minus 1/12 is 4 twelfths. 5 minus 3 is 2 6. 4 divided by 12, or 4 and 12 both divisible by 4. 4 divided by 4 is 1. 12 divided by 4 is 3. And that gives us 1/3 2. And I see that it checks. So that's our answer. And since it came out nice like that, I'm assuming that those y's were actually in the denominator.